Oh, hey everybody.
What's
Welcome
up,
to
everybody?
the training stream. I'm Alex. I'm just kind of here to help moderate and hang out. But Sam Dieter here has got some pretty impressive stuff to show you with blueprint drawing to render targets. So yeah.
All right,
Do your
yeah.
thing,
So
man.
as Alex Zander gave me a great intro, so today we're going to go over one of the new features in 4.13, and that is how to manipulate render targets using blueprints. So we're going to show you a couple of examples. A very slimmed down, simple example. A way to use another new feature in 4.13 is new noise generation material expression.
Yep.
We're going to use that in combination with the blueprint render targets to give us the ability to make a new texture that's all procedurally generated inside of Unreal. And then we're going to look at a very simplistic height map painter, which is basically you shoot at the ground and that part of the ground will rise up in front of you the longer you have your mouse held down. And it's again, these examples that we're showing you today are very simplistic, just to kind of give you an idea of how this system works and what you need to do to use it. So before we jump into it, there's a couple things I'm going to paste into the chat message here, the chat log. I've got these following two pages from our resident tech wizard, Ryan Brooks. Let me just bust this other one in there for you guys. So this first page, this shader bits page, while this isn't directly related to blueprints and render targets, it is a little bit because it's about the dilation of textures, or it's about the dilation and padding that you have with some textures. Long story short, when you go to render sometimes, you'll get sometimes a little pixel error, maybe on the edge or a border or something like that, and that's what this blog is talking about. The other one, which is getting the most out of noise in UE4, this one right here is actually, this first part is actually one of the first examples I'm going to show you guys today, came directly from this blog. But there's a ton of useful information, not only regarding to using blueprints and render targets, but also how to make procedural textures inside of UE4 4.13. And it also is going to give you down here at the bottom, you get to see this really kick butt looking smoke. Thing looks amazing. And then down here, right here we have the instructions, basically how expensive this noisenoid costs per octave level. So great information in here, definitely worth checking out. So with that out of the way, let's go ahead and jump right into our map. So the first thing that we're going to do today is we are going to start with our blueprint render target to create a texture. So I actually have the texture right here. So basically, all we're going to do, if I wanted to make a new one, is I right-click on it, I create a static texture. I have this texture right here. So let's go ahead and we'll open up the material first. I was trying something else. So here's what the material looks like, right? And you can see it is let me expand this window a little bit. You can see there's just some randomly generated noise in there. Now, how this comes about is I have this material expression thing called the noise parameter. And then in here, I can do things like I can decrease the size, I can change the different type of noise, I can turn turbulence on, and then when I hit compile, oops, and it hasn't updated yet because I need to put my actor in there, but if you see right there, you see the render target updated. If I right click on this now and create another static texture, you can see here, oops, and let me pull this back onto the screen here and turn off the alpha channel for you guys. So you can see this is one that I created, and then this is the second one that I created. Oops, got alpha channel on. So you can see two totally different styles of noise, all created using this material and then rendered out using this blueprint. Now let's open up the blueprint and check that out. Now this blueprint is actually incredibly easy to make. So what we have here in the components, let me click over the viewport really quick. We just have this box. The box is merely there so that I can grab something in the viewport and move it around because I have to move it in order for it to update itself. Okay. And then I have a render to texture here, 2D, and then a material interface. Okay, those are the only variables that I really needed to add was this one and this one. When we go over to the event graph, and you see there's actually nothing else. This is literally the event graph. I told you it's very, very simple. Basically, what it's doing is it has a custom event called bake, and then when bake is called, it's going to draw material to the render target. This is going to accept a render target here, and then a material that you want to use here. So inside of the construction script, it's just this. All it is it's calling the bake, right? So when this thing is run, basically each time this is moved, and the material has been updated. So let's update the material one more time. So let's bring the levels all the way down, and we will, I don't know, I'm just going to do some random stuff here. Ooh, that looks kind of cool. Let's keep going something like that. Okay, we're going to compile this guy. Okay, now you see that it's updated here, but it hasn't updated in my texture. If I just move this guy over, it'll update my texture, right click, create static texture. And you see I've got 1, 2, and 3 static textures that I've created just by simply manipulating that node.
Yeah.
And you see this very, very simple process, a very, very simple blueprint setup. Now, if you guys are, oh, well, yeah, I have tons of questions and stuff like this, all of these examples that I'm going over today are examples that I've actually already built, and they will be in the documentation for this. So we are literally going through the examples that I will be providing for you guys in the documentation.
Yep, because that's definitely what people are going to ask for.
Yep. So, do we have any questions so far about this? Has anything come up or anything?
We've had a couple of questions come in so far. Let's see here. Can you guys make an example of doing blood splats? I guess a better question would be, is this something that you would use to make blood splats?
I wouldn't use that system to make blood splats. I would use decals. You could use this to make blood splats, but it would be like using a bazooka to kill an ant, in my opinion. There's better ways to solve that problem, such as decals. So if that was the only question about this one, we'll move on to a little bit more of a complex example. So let me delete that and come over here to my Blueprint to Render Target. Whoops, wrong thing, Height Map Painter. And let me put this guy into the world. And oops, it's got a little bit of Z fighting going on there, so let me raise that up just a tiny bit. Okay, now with this one, what's going to happen is you see as I move around the world, I'm increasing the height of this plane, okay? Now this is a very, very simplified example. I'm not actually moving the collision, I am just moving the render geometry. So basically, you could use this, we had a question in there about like, can I use this to make an effect like manipulate the terrain or something like that? And unfortunately, you cannot, let me rephrase that. With its current setup, you would need the ability to adjust the collision at runtime, and we don't have that option currently inside of Unreal Engine 4. This right here, this is just manipulating the vertices, so it's just moving their position and the world and the z-axis up.
Yes.
So while it looks very cool, it's very, very simple. It's literally just using the render target to dynamically adjust the position of those vertices. So let's go ahead and jump into the how this is set up. So first off, all my assets that I have are right here. I have this crosshair texture. This is mainly just for this right here. You can see my little green crosshair in the center of the screen. It's just so that the user can know where they're aiming about, because you need something like that. We have this static mesh plane. Again, this will come with the content examples. Now, it's going to take a huge time to load up because this is like 500,000 vertices.
Yes.
So
that should probably be thoroughly explained. Like you were saying, like when we're adjusting this, we're moving the verts, so it can only move the verts that are there. So the lower poly it is, the less of this smooth gradient you're going to see. So that's why it looks like nice hills. But if it was low poly, we would just be like.
If I look at this guy in wireframe, he's like,
it's a solid color.
I turn on his collision, but I'm afraid I'd crash the computer. So I don't want to do that. But again, the reason that this was so heavily tessellated is so that we can give a good example, so that we don't have to worry about, here's the reason this isn't working because there's not enough tessellation. Is there too much? We're trying to alleviate as many problems as we can, so we can just focus on the tech. So let's go ahead and start looking at the material. So the first one, I'm going to open it up. This is the material for the crosshair. Now, something that's unique about this material versus the other materials is over here in the material domain, you can see I have this set to user interface, and its blend mode is set to translucent. This way, it's translucent when you actually see it on the screen, so you can see things that are behind the radical. The next thing we're going to look at is we're going to look at this matte splat. Now, what this guy does is, let me see if I can, there we go. See this little dot right here? This is what is going to determine the location and basically the size of the hill that is going to be painted. What this material is doing is it's basically taking this vector 3, it's masking out 2 channels, so you have an X and a Y. It's subtracting the texture coordinates from it. It's putting it into a 2-channel vector. So basically what we're doing is we are setting this thing up so that it can work as our paintbrush on the canvas. We then have our size. So this is going to be the size of the object itself, like how wide that this little paintbrush thing is going to be. And then we have the strength, or how it is going to affect the underlying geometry. On its blending mode, we have it set to additive and unlit. Now this is very important because this effect is meant to stack on top, so I can paint over once and have kind of slightly lower hills and then paint again and again and again, so I need to add that stuff together, which is why this effect needs to be additive. You can mess with other blend modes, but I can't really guarantee what results you're going to get with them. Then we have the height map itself, and this is the material right here. The reason I have a texture in here is you need some type of texture data to sit in there, okay? And this is actually going out to just one of the,
one of those noise.
Yeah, one of those
textures.
Noise textures right here. It's actually going out to the render target one. What this is doing is basically we have our height scale here. We're multiplying it by the red channel of our render target, and then we're basically turning this into a value that will only raise stuff up in the z-axis, and then we're plugging this into the world position. So again, this stuff's very, very simplified. Oops, go back over here. So we went over the height, we went over the splat. So the other 2 things that I had to set up for this, because I needed the ability to have a radical, is I had to set up a game mode, which I literally just, in the side of the game mode, you can see only thing that I changed was the HUD, and I changed it to this HUD right here. And the reason that I did that is so that I could have this. This right here draws a crosshair in the center of the screen, and this might look very familiar to a lot of you because this is the exact same blueprint that comes with the starter content that actually is used to draw the radical in the center of the screen. So this is the exact same code. Most important thing about this, if you're going to recreate it, don't forget to apply your material here, or you're going to be scratching your head about why you can't actually see anything on the screen. So that is it for basic asset setup. Again, it's fairly easy. Oh, one other thing, the blueprint right here. This blueprint was based off of static mesh actor instead of just actor. If you try and make one based off of actor, we need to get a static mesh component.
So it was just easier to
it's just easier to base this off of actor. So let's go ahead and open this up. Now, before we jump into anything else, I'm just going to go ahead and go over the variables that I had to have. So this is the height field. You'll notice that this doesn't have anything inside of it. That's exactly how it's supposed to be because we're going to dynamically set all of this stuff up inside of the blueprint. Okay, we have our interaction distance, which is a float. This is basically how far in the world do I have to be so I can interact with an object. Okay, we have our brush size and our brush strength. So right now our brush size is 0.04, and our brush strength is 1. And you notice that all 3 of these ones, the interaction distance, brush size, and brush strength, are all editable, so you can edit them to fit your needs and your particular level. We then have a mouse down. The mouse down is to deal with shooting. It's just to make sure that we have the mouse down that will run this particular function that we're going to get into.
Continuous check.
Yep. Then we have our painter material instance dynamic. One cool thing I just want to interject, you guys might not know this, this was something I found out yesterday. Sometimes it's a little hard to see over here what variable they're actually using. Like, is this a material instance, reference, or an actor, or whatnot? If you actually hover right over here, you can tell exactly which type of parameter it is. I don't know if you guys know about that, but that was something that I just found out about, and I thought that was really super useful because a lot of times I was trying to guess because it's kind of cut off up here sometimes. So just a cool little tidbit of some information I found. Both the painter material and the force splat material instance dynamic you'll see that they have nothing loaded inside of them. That's exactly how they're supposed to be. We're going to set up that interaction, or what's going to dynamically load a material into that, and another section here. We have the render to texture size for the width and size for the height. And then we have our collision UV hit, and I'll get to this in a little bit. This is actually using a new 4.13 feature that is basically getting your hit results from the UV of the object. Instead of having to write an entire bunch of Blueprint logic code, which I'll show you in just a little bit, you can replace this using just this one singular node. You will have to enable that in your project settings, but I'll cover that in a second. So with all of the variables, let's go to our construction script. So the construction script for this, what this is going to do is it is going to basically initialize our render target, set up all of our material instance, our dynamic material instances, make sure that everything is ready to go so that when we go and play the level, when we go and launch the level, the ground will be completely flat, and then we can start to shoot everything. So first off, what we do is we create the render target and we give it a size. And our default size is 256 by 256. Before you start going crazy with the render target size, always make sure to test it first, because you could think that you might need 512 or 1024, but when you go to test it, in reality, you find out, hey, you know what? 128 or 256 actually works just as well, and nobody can tell. You're always going to want to go smaller. Smaller is always going to be better with the render targets, just because you are adding a whole bunch of extra data that you're going to have to push down the pipeline.
Yeah.
Okay, so the next thing we're doing is we are setting the height field render target. We are going to create our dynamic material instance for the height material. So that was this material right here, the material that controls the elevation of the object that it's placed on. We are going to set our painter material instance, and we are going to set this on our static mesh component, which is this dude right here. And then we are going to create our dynamic material instance for the splat, which you can think of as the paintbrush. And then we are going to set that. Okay, and that's the event graph. Basically, all we're doing is we are setting stuff up, getting it ready to render. Before I jump into the event graph, what I want to do is I want to jump into the trace from camera really quick. Now, you can see this right here. What this is doing is literally just tracing from the center of the camera, center of our camera, out into the world. So to do that, since this is a function that we're going to call, we have our trace from camera, which goes right into our line trace by channel. All of this right here, this get player camera manager, get actor location, get actor rotation, get rotation vector, normalizing it, interaction distance, all of this stuff right here. Basically, this is just starting where, setting up where the ray is going to start and where the ray is going to end within the world. We then go into our line trace by channel. This is going to handle the line trace for every single time that that it's fired. When it is basically when it goes, we have our branching statement here that says if it's true and it's a valid hit, what are we going to do? Well, first off, we're going to break our hit. We're going to come over here. We're going to see on our hit actor, is it valid? Yeah, it was a valid hit. Okay. We're going to set our collision UV hit, and this is going to go into our find collision UV. Again, what this is doing is this is allowing us to use the UVs of the object to determine where the object was hit, instead of having to rely on the collision mesh itself. Okay, and this is a new feature in 4.13. And one other thing I need to say real quick, sorry. To enable this particular feature, the find collision UV, you need to go up to your project settings. Wait, I always screw these two up. It's either editor preferences. No, I think it's project settings. Yeah, I'm pretty sure it's project settings. Physics, and then I think it's UV. There we go. So support UV from hit result. Now, by default, this will be disabled, so you need to check this on. Now, you will need to restart the editor in order to see these changes. There isn't a pop-up box that says, hey, restart the editor. But you will have to do that. I spent about 20 minutes yesterday trying to figure out why this wouldn't work, and it's because I needed to restart the editor. So you will be able to find this node without enabling that option, but it just won't do anything. So that's why you need to go ahead and enable it. So we have our apply point damage. So what apply point damage is going to do is it's basically allowing us to tell the surface that's underneath that, hey, at this spot where we clicked, we want to raise the surface up. When you do apply the point damage, don't forget to put in the base damage, because this will default at 0. And of course, 0 didn't actually go in there. Did my number lock off? There we go. So if you do not set this base damage number to anything else besides 0, nothing is going to happen with your effects. So just set it to, my keyboard is not wanting to work with me here. So I have that set at 100. So, and that's it. This is all that this function is going to do. It's relatively simple. So let's go to our event graph here. So the first thing we're going to do on our begin play, we are going to enable input. If you don't do this, when you come in here, you'll have to come over here to enable input and then enable input on player 0. Do you have to do this? No, but this will this will save you a lot of time wondering why this thing didn't work when you placed it down inside of the level. I kept running into that, so I ended up just adding this enable input because I kept forgetting to do it each time I go to show somebody it or something like that.
I think you can also set it in the defaults.
I think you can too. I think I realized that.
Sure that's an unnecessary one.
You can do it like right here as well.
Input. Yeah.
Yeah. So I figured that out after I had already put all this stuff in there, but it's another way you can do it in case you forget to do it there. This next thing, what we're doing here is we're going to clear the render target of data. So if you look at the render target now, and if I go in, you can see how it's slightly raised a little bit.
Yeah, where all those white spots are.
Yeah, that's because it's taking the height from this render target right here, because we're manipulating the world position. When I go play, though, you see how it turned black, completely black.
Yes.
That's because right here, what we're doing is we are basically clearing the color to black. We're clearing this height field RT, so this guy right here, we're clearing it to black. And then we are initiating our height field value. We're getting the material set up ready to paint. Right here, what we're doing is we are checking to see if our left mouse button is down, or basically pressed or depressed. And then if it is pressed, what we're going to do is on each tick, if this is true, we're going to come here and we're going to run our trace from camera function. So when the mouse is pressed down, we're just going to be tracing out, throwing a line out each time. If we release the mouse button, we're not going to be tracing anymore. Very, very simple stuff. Now we're going to get into the kind of the meat and potatoes of everything and the apply damage function. So first off, we have our event point damage, which is related to our, where do you go? Our apply point damage right here. So we are going to, off of this, we're going to set our scalar parameter value. And you see I have force size right here set to the force splat material dynamic instance. We have our brush size for one of the values. The next one, we're going to set up the scalar for the strength, which is the brush strength. And then we are going to set up the vector parameter for the position. And the vector parameter for the position is that little white dot that I showed you that basically acts as the paintbrush. Okay, and then finally, the last part is we're actually going to draw all of this stuff to the render target. So that's what's happening right down here. Okay, we're actually going to draw everything to the render target. Over here is my force splat. Basically, this is the dynamic material instance that we created and set up in the construction script. Now we're going to feed it to all of these different inputs, and then we are going to use this to initialize all of the data. Now this, let me move something out of the way really quick. We'll pretend like this one doesn't exist just yet. This right here, what this is doing is this, so we're getting our static mesh component, we're getting its world transform, we're inverting the transform, we're finding the transform location, we are taking that vector, dividing it by 1,000, and then we are actually feeding it into a, this is a linear color, so that we can get our position, okay? Now, the reason that we're doing that is so that we can basically have a location where the hit is going to take place. Now, all of this stuff right here, this entire functionality right here, can actually be replaced by this, which is this new node that I talked about that's available in 4.13, the Find Collision at UV. So basically all I did, and this doesn't actually need to be connected, I was doing some testing earlier. So basically all we're doing is on our location hit, okay, at the location, oops, and I need my static mesh component back up over here. So we are checking to see which actor is hit, which is the static mesh component, which is this guy right here. When that's hit, what we're going to do is we are going to do our line UV trace out, and that's it. This right here, this collision UV hit, is this from this parameter right here that we made earlier. And what this is doing is it's basically doing the exact same thing as this code. It's going out, it's figuring out, it's getting the transform, it's inverting it, it's transform its location, and then it's basically converting it into 2D coordinates.
Yeah.
So all of that functionality, I just got rid of all those nodes and basically put just in this and put in this little bit of logic right here. So I was able to condense all of that down into these 3 nodes, which makes it super duper handy. So now when I play, I can see, I do this. If I come over here and I select some of my options, let's see. Oops, that was all the way down at the bottom. So let's brush size, we'll bring that up to 1. You see my brush is huge. Let's see, we'll set this back down to 0.05. Maybe if I bring the brush strength up, we'll say 5. It's probably going to make a massive hill. Yeah, it just shoots like straight up in the air. So, all right, so that is it for the blueprint, manipulating them through blueprints, manipulating render targets through blueprints, and using 2 different methods. Now, the contents examples will have a 3rd example, and that does a fluid surface actor.
Yeah, that's the water splash.
Yeah, that's the water splash one. That example is a lot more in-depth. It contains a lot more custom functions.
Yeah.
It probably would have taken an entire stream all into its own to describe the functionality of that one, but I did have enough time to document it. So each part of that, each section of how you build the water splat, or basically the fluid surface actor from Unreal Engine 3, because that's basically what it is. Yeah. You'll be able to break down each part of that. So let's see if we got any questions.
We have a ton of questions.
Okay, so
we should start with the ones from the forums.
Yeah, let's go ahead. I'm just going to start at the top of the questions here. It says, so the first question, can this be used also to alter the collision and or navigation of the surface via displacing the surface, creating tall mountains, deep ravines, but with collision?
Yeah.
If so, how would this impact performance? Most likely not.
Yes.
I would think of this more as a visual. I want to. I just had an idea and I just totally fell right out of my head. Like visual icing on the cake.
Yeah, it is very much so an optical illusion.
Yeah.
It is. Actually, if we show this again, can you show the collision and then show it like at runtime when we're altering it? So this is kind of an important thing to take into consideration. There is no collision change here. This is only showing a mesh change, but the collision does not change dynamically at runtime. So you can actually kind of see it's very faint, but this plane is big.
You see that line right there? That's the collision right there. Now, if I go along the edge like Alexander was talking about,
you see that line just gets exposed. It doesn't actually move up with it. So this does not have collision. This is purely aesthetic.
Yep, but that doesn't mean you can have some cool effects with it. Again, we've shown ways you could actually make anything that you could do inside of the material editor with this first setup, the creating textures. With just this setup right here, you could make all of the materials that, or all of the source textures that you would need for your game. You can make them right inside of Unreal Engine 4. Let's go on here to the second question. Could it be used to permanently affect the terrain of a map, scar the surface without need to garbage collect it, the scars?
Again, I think this one falls back into there's no collision, so it's not really going to help you out. I mean, you can visually alter what you're looking at to maybe do some minor things, but if you alter a hill, the hill collision will still be where it
so
was.
basically you would, in a perfect world, you would, say, push the terrain down, but it would just be visually pushed down. The player would still be able to walk over it. So as the player walks over that, all of a sudden they're just going to be walking in the air. You would, to get something like that, you would have to modify the actual landscape code itself, which opens up a whole other kettle of fish. Also, the problem that you would run into would be blending this together. That would be another problem, is how am I going to blend this thing that I just splatted down on top of the surface? You're going to run into some edge cases where it doesn't necessarily line up correctly or things like that. Let's see. In the content example, the surface normal, which you paint, remains flat even as the ground becomes mountains, and you still have to aim down at the surface to continue painting.
This is interesting. We had a really interesting discussion just before the stream about how you would resolve this. So we'll hop back in there to explain the question. Is that so? As we're creating these hills and mountains, which are a little extreme here.
I should probably put the strength back down, but
if you want to hit, there you go. So if you want to like grow the mountain thing, so what this is asking is, you have a mountain, like one of these lumps right here that we have going on, and you want to just say like, oh, I want the top of it to be taller, so you try to click the top, but nothing happens. That's because the collision didn't go anywhere, and since the hit is based off of collision, that doesn't work like that. So we were talking about how would you resolve this? There are probably a few different methods, but they're all going to be a little not performant. My thought was on that where you're hitting it on tick to also add in a piece of new collision, like an invisible sphere or something that moves up an appropriate amount to match the height of what you're pushing up, and then that way you could click the tip of it to make it alter. But at that point you're generating just hundreds of collision bodies at runtime to do that.
Yeah, it's something similar with having a mesh that has per poly collision on it, but hiding it underneath it so that you have like your game mesh, then you have your regular mesh, but then it would be hidden. So I was thinking maybe you would put an opacity mask on it so that it's there, but it's being rendered invisible, but now you have two meshes in the world. So that's, you know, there's all of these things that you have to consider when you want to do something like this. Now, that's not to say you can't do this. It's just you've got to think about it, right? And
you have to kind of think about
you got to kind of plan what you want to do with it.
How is this actually going to be used in your game, and how would you expect the user to use with it? And then you can plan around that. But yeah, if you just kind of go in there trying to make up stuff, it might not go over well.
So here's another one that we had. And I actually just had this happen in this example. When we were looking at it.
So mountainous surfaces get clipped out of the scene if the ground surface is out of view. How do you fix that?
So you can see right here, I get it. So it's like right in this area right here, I'm starting to lose it. And one of the ways you can go about
this is just the simplest
quickly,
way, really.
Fix this is we can increase our bounds scale. So I'm going to set it to 20.
Basically, anything that renders at all has a bound scale for when it's going to be rendered. And so now he can look up, and the bounds are massive.
And sometimes you will run into instances where the bounds isn't big enough. I think before I was testing this out, I was using like a bound scale of 10. And then there would be like one point where I'd look, there we go. See right there, I can make it disappear just a little bit, but it's like right in this one spot. And again, to do that, you come over here, you select it, you can search for it.
Or it's underneath the rendering tab.
There we go. I just like to search because I'm lazy. And then you can just set that here, 50 or a 1 or whatever. But that will help reduce that. I don't know if it's going to completely eliminate it for you because it's also based off of the actual size of the object. So another way would be to not only increase that, but actually physically increase the size of the object by scaling it.
Because then it just naturally scales to the size.
Exactly. How
can we create render target in a blueprint with a certain format, e.g. only one channel to render height field?
I haven't done this, so I'm not sure if it's possible or not. Like, I think they just maybe want to render out the red channel or the green channel or something like that.
I mean, you could maybe do that in a material where you just isolate that channel.
Wait, let me see. Where was it?
Because that could be kind of interesting, like at runtime, if you have a very blotchy noise kind of map, but it
Mhm.
has like 3 different channels of noise, and then you just swap between what channel it's reading.
Yeah, so you like do RGB mask packing.
Yeah, yeah,
Okay,
yeah.
okay.
That would
Um,
that would be kind of interesting.
Where is that thing at? Oh, it's in here. I mean, from here, what we're doing is we are actually reading. Wait, is it the rendered target or the texture? I think this is the rendered target. Yeah. From here, from this one right here, we are reading from the red channel of the rendered target, which means you could probably read from the other channels. But I don't know if you could, using this methodology. I don't know. There is the blueprint render to texture functionality that Ryan Brooks made. That has the ability to render out every single channel that you want, so base color, normal, roughness, specular. Yes, you could do it with this, but it would require a lot of trial and error and a lot of setup to get this working.
Yeah.
And I don't know, I haven't spent any time looking into it, so I can't really work it out in my head how I'd go about doing that. But that functionality actually already currently exists using the render to texture blueprint that Ryan Brooks made. So yes, this could be possible, but there are better ways to go about doing it than just trying to isolate a channel and render it out, if that makes sense. So yes, this would be possible, but again, it's a lot of things in video game development. Is there are things that you can do, but there's always a better way to do them, or an easier way, or a way that you don't have to constantly bang your head against the keyboard to get it to work.
So probably not this direction for that.
Okay, would it by any chance be possible to break down, to do a breakdown of the examples, like briefly explain what each section does? Yes, that will be in the doc. We will break down this one, this guy right here, this guy, which is the texture creator, this guy, which is the height map painter, and we'll break down one more, which is the fluid surface actor. Here's another good one. Is it possible to use this technique to render liquids inside of an object like a glass bottle? No, that's not really what this is for. If you wanted to do something like that, I would suggest you look into morph targets. This is mainly more for surfaces that you need to display some type of like dynamic data. So like the surface is moving, or the surface is deformable, or something like that. That's not really what this is built for, or what you would you wouldn't solve that type of problem using this type of tech. Is what I'm trying to get at.
I think to kind of come back to the core of what the functionality here is, this is purely visual, does not affect collision, and is going to be something that you go to for. We're probably going to show a couple of examples too, because there's some really great stuff out of the community, but it's just for visual enhancement of other things that are happening more than anything else.
So let me see. Is there a way to directly convert overlap collision to texture? Specific scenario, an energy shield that registers overlaps with bullets but lets them through. The bullets should then cause wave-like ripples in the energy shield. Yes, you could make wave-like ripples in the energy shield using this. However, getting that functionality, getting that to work, I don't know enough about line traces to know if you could do that.
I think that actually, I think kind of with what you've done here today with just the with that, like it's the same basic technique to do anything. It's that hit and then render target. And so instead of doing it on the height map, kind of looking back at that fluid actor, you could maybe do it like that. But one way or the other, that object is going to have a lot of polys. Like that shield is going to be, like if you want that ripple effect to look very good and not have artifacting, it's going to be pretty high poly to do that effect. Well, I would almost recommend doing it as like a temporary decal that shows up.
Yeah,
that has like some normals or something.
The fluid surface actor does have a compute normal, so it does have an actual normal map normal that you can use to, because there's two methods for flecting the surface of that one. There is shooting at it, which will give you the ripples, but then your player can also walk over it, and that will give you these very subtle ripples. And those ones I do believe are all done within the normal map.
Oh, okay.
So you do have that functionality, but Alexander is right.
Yeah, it's probably safer to go through the material itself yeah, like you said, normal map is probably the best bet there. Really,
It would be possible to do. The problem is, though, is that having that trace come through an object, because we all have wanted to play games that have bullet penetration.
oh yeah, where it hits once.
Yeah, it hits once and it goes through, and either the bullet penetration isn't very good or it's too good, and the dude can snipe you from like half a mile away through 6 closed doors and 7 people.
Yeah, like for the effect overall. Okay, so kind of like getting back to it, like yeah, you can do multi-line trace, etc. to do this like line trace through it, hit it, and all that. Is it going to be performant? No. I wouldn't say that by another technique of using like a decal or normal map, it's not going to be anywhere near as performant as that. It's going to be much heavier when you're moving vertices around like that. So probably.
Oh, there's one thing, and it's totally forgot about this. This is super important, and I am so sorry that I forgot to mention this. See this allow negative emissive color? You need to enable this because a lot of these effects need to be plugged into the emissive channel. Well, the emissive channel goes 0 to 1, right? So it just allows you to go 0 or 1. It doesn't allow you to go 0, -1, or 1. What this checkmark box does is it allows it to go negative. So you can have -1, 0, and 1 going into the emissive input. And I apologize for forgetting about that parameters. That one is very important.
Because that's actually a question that quite a few different people asked. Is like since you were showing the height going up only, could you have instead made it go down?
Yes, I just didn't add that.
Yeah. It's a yes. And
I started looking into it, but I started burning more time trying to figure it out than I had time left in my tasks. So sometimes I have to just be like, okay, I got to put this down and pick up something else. But yes, you could totally do that, and that flag will help you do that.
Yes.
Could this be used to add ripples to character skin, like when a boxer punches another boxer in the gut and the shockwave ripples through their body? Yes, you could. But as I was thinking about this, like, I would have to do something like maybe I have this part of their chest right here is a super, super high poly dense mesh that I can then swap out with a lower density one. So it's like a slow-mo scene. So the dude gets hit in the gut, and then it's a super high density mesh that shows that ripple. And then when that's over,
it goes back into the lower poly.
Yeah,
this actually makes sense. This is almost like the sniper elite technique, where once like everything's a regular amount of poly, and then when you hit the sniper shot perfectly, it goes into the super high poly version where everything's got internal organs and all that, and you see the rippling effect as it has that punch through everything. And so that would probably be the best way to handle that technique.
And while that does sound very simple to say, in practice, that would be something that would be
pretty difficult.
It would be difficult to implement. It's not impossible, but it would take a lot of trial and error to get correctly.
Yeah, I mean,
to get correct. I'm sorry.
Yeah, and then you can just do basically you have the fist come up, and there's like a little line trace coming out of the fist, and then when the fist hits in that little area, then you have the ripple effect come out of there. But,
can the paint shape be something other than a circle or a square? The paint shape can be anything you wanted. The reason it was a circle is because I was making it with math.
Yep, so it just made it perfect radius.
I wasn't even really making it. That was Daniel Wright was making it with math.
But yeah, feel free to inject your own texture shapes and make little unicorn-shaped ones or whatever. It's your game. Do what you like.
So one is it possible to make a material change based on the position of another actor in the scene? For example, making a wall turn red as another actor moves across it as if it is painting on the surface.
Oh.
Basically, I think what they want to make is a whiteboard painter, and if you check out this thread on the forums, somebody actually made a white.
Yeah, you can bring that up.
Do we have a link in here?
You know what? I thought we did, and we don't. It's forums.unrealengine.com. Whenever you want to learn anything interesting new, just come down to the forums. We're just full of interesting information. It's under events, and then there we are. And I think we even had more questions show up since we started. So if you scroll down, we'll put this over here.
Let me show you guys. So this is the one that I was talking about, the fluid surface. You can see those ripples right there. Those ripples
I just post that everywhere because everyone loves seeing that.
Some of those ripples are normal maps, and some of them are actual surface tessellation.
Yep.
Let me see. This is the whiteboard that we're talking about
give credit where credit is due.
So, scroll up. Oh, there we go.
Yeah, Jay Wainwright. There we go.
Jay Wainwright. So hopefully, maybe he will share this with other forum users so they can check out how he did it. But this is something that you can totally do with this functionality. And it probably works way better than the one in Duke Nukem 3D. Then let me see. We had, what is this? Devastate 3D did this really awesome looking dynamic rain drips coming down. I think this looks really cool. Was that it? Did we have another one? Oh, the other one was the bullet holes, but I don't know where that is.
Oh, I don't know. I found that one on Twitter, but that was impressive. There was, someone has posted about making bullet holes with this, basically the idea is, so when you go negative, there's also what we think he's done is actually we're kind of guessing at it.
Yeah, because we're not 100% sure.
Yeah,
but we have our best guess.
Jump in here real fast and kind of shooting off the thing again. So when it hits a certain threshold, so see how it's very powerful.
Let me turn the power back down on that.
But yeah,
power level 9,000.
It's alphaing out. So what we saw is there's a gun that he made where it does a line trace out, hits the far wall, and then does a big punch through it. And the way it's punching that hole through is, it's doing one of these very powerful draws, and then when it hits a certain threshold, we think it alphas out to turn invisible, which is very impressive because if you go on the other side of the object, you can see
it looks like it's actually
it actually punched through the metal. It's very interesting to see that. But yeah, so you can see we're kind of hitting threshold and it hits like a white. Instead, we could, put in a break there. It's pretty impressive.
Does this work with dynamic tessellation? I don't know. I've never tried it with dynamic tessellation.
Oh, yeah. I mean, I don't know why it wouldn't.
I don't know why it wouldn't work. I would just not dynamically tessellate this mesh right here, but try one that has a little bit of a lower tessellation value on it.
Oh, goodness. If you go back to that forum post.
Oh, wait, hold on 1 second.
There we go. So if bring it back over here so we can show it. Okay. So keep going. Check that out. So chat was just telling me about this, and apparently this is an ocean shader or simulator for it. That's impressive.
Oh, cool.
Really impressive.
That's awesome.
Yeah. Probably a little overkill, but very.
Talk to Ryan about his waves.
Yeah. Oh, yeah. We should have Ryan Brooks come on and just sit here for 2 minutes with the thing because
he's made some awesome stuff with this. So let's see what else can we
TK Master, excellent work on that. Really cool.
Would this be possible and optimized in a multiplayer game? That question is very, very, very hard to answer because the answer to that question
it depends.
It depends
on how much you've put in there. But
it depends on.
Can you replicate it? Is the first question. Can it be replicated?
I don't see why not.
Yeah.
I don't see why. I don't see anything like glaring like, oh, this would never do this because of collision, because this is just a render effect. So you're just moving the vertice positions.
Mm-hmm. Yeah.
Nothing is immediately jumping out at me, but I think you probably could, but I'm not.
It's not something you've personally tried.
Yeah, it's not something I've personally tried. So
try it out. Get back to us if it doesn't do what you expect, and we will try to help you out with that. You can lower as well as raise. Yes. Yep. You can go both up and down. Let's see here. Someone has asked, I'm wanting to render out a live audio frequency spectrogram. Would this be recommended approach for such renderings? Recommended, not recommended. It's an approach you could take to rendering that out if you wanted to, I don't know, like have a series of like hits, I guess, or places that it would raise and lower based off of this dynamic information.
But I mean, I would use to approach something like that. I would use morph targets.
Oh, really? I was gonna say I'd just use meshes and scale them, because I'm lazy like that.
Oh, yeah. Well, morph target will allow you to get you can basically go, full to 0, but it's along a 0 to 1, so you can control it anyway. But again, he does it this one way with meshes. Yeah. I do it one way with morph targets. Like, neither one of those ways is right. Neither one of those ways is wrong. They're just different ways to solve the same problem, which is one of the reasons why I love game development so much.
There's so many different things. Like you were saying, like you have a max and a min. Well, you could do a scale and clamp it. So it's lots of different ways to do this.
Could this be used for hit masks on skeletal mesh to produce blood at impact points on animated characters?
They went back to that because they wanted to clarify their question was actually for animated characters and all that. But What I did for this is I tried this before with tattoos on a character and how to apply, like go to a store and then have them like buy tattoos and apply them. And I just socketed decals, but this is probably like they want to attach them to wherever the thing hit.
I mean, I would use physical materials for that.
Yeah, that makes sense.
And then, you know, that would deal with the blood. This system, I think, would be a little bit overkill for that, in all honesty. Unless you were doing like some crazy gore system. Yeah, I think this would be a little bit overkill for that.
Yeah.
Because even the awesome gore system done in Left 4 Dead 2 doesn't use anything like this. It uses like elliptoids and it makes volumes. You might use some of the stuff that Ryan's working on now with the volume texturing, but this particular method doesn't strike me as something that would be super useful for that. It seems like you might end up fighting the system more than actually, you know, getting it to work for you. Let's see, can you do the same with a radius area damage rather than point and affect a larger area of the mesh on a more complex mesh? I mean, the point damage I think is the simplest one, but that radius, as you saw, like I have full control over how big that is, so I can make it itty bitty tiny or absolutely ginormous.
And it doesn't have to even be like from the point extending, though. You could just have a circle and then have that all move up uniformly.
Like yeah, you could do that as well. You could have it move up in steps.
Yeah, so there's no limitation there for
performance
how you
for
want it
VR.
to work.
Acceptable, not so much. This is one of those big questions. You could use this in VR, sure. What other feature are you going to get rid of in order to maximize this? So
it's that balance question.
You know, you're like, I don't really want to do any static lighting, you know, which you should for VR, but let's just say that wasn't a thing. Then you're going to have to say, well, I can't afford this and dynamic lighting, so what do I want? Well, this gives me all of these features. Now I need to go turn on my lights static, Control-Shift, comma, profile. Let me see what I'm getting. Okay. Oh, I see this thing's still really expensive. Oh, you know what? My directional light is still fully dynamic. Static, build, Control-Shift, comma, profile. See what it is that you are going to be getting back as your performance. Because again, it is a trade-off, especially with VR. You're going to have to get rid of something in order to have this. What you get rid of is up to you and what your project is trying to do.
And this is again, since this is visual, this is going to be more GPU side of calculation anyway. And yeah, like he was saying, this is scalable. This is something that, like what we have here to show you a very fluid-looking, very smooth-looking surface is a really, really high poly mesh of a plane, right? So you don't have to go that high poly. You don't have to do what we've done here. And instead, you could just go like, you can make it lower. It'll maybe look a little bit more rigid, but it'll save you on some cycles.
It'll also save you some actual memory because that mesh is massive.
Yeah, that mesh is, it's for demonstration purposes only, really.
Does this affect GPU particle collision? I mean, depending on which one you're using, if you're using mesh distance fields, I never actually turned on mesh distance fields, so I'm not sure.
But the collision isn't going anywhere.
No, the collision isn't going anywhere.
So it would collide with the initial plane.
Yeah, it would collide with the plane it came off of, but I don't think it would collide with the ridges that you're putting in there because there's just, unless they are picked up and you're using depth collision.
Oh.
Instead of, because you have two options with GPU collision particles. You have depth only, but depth
GPU collision particles pre-made on here.
Well, depth, the depth ones, they have that problem where if I look away and I have a bunch of particles here, they just all fall to the ground at once. So it looks like I just dropped a bunch of particles because I don't have any depth information over there. The other way to do it is to use the signed distance fields, and then you can have GPU particles collide on there.
Okay, well, all right. That's getting I mean, they're definitely correct ways of going about it. That's just getting like, okay, well, we'd have to sit up and like set up some things to double check it and test, but sounds feasible, but just not off of the base collision.
Let me see. Is it possible to create a render target that only has a red channel, like a 32-bit? No, render targets are always, and to make a render target, you right-click inside of the content browser, you come here to materials and textures, and there's a render target right there. If I open this guy up.
Wait, back up and do that again.
Oh.
You reading a book?
Oops, that is not what I wanted to make. 1 second here, guys. Let me just delete this again. Okay, so to make a render target, You come here to, so right-click inside the content browser. Under Materials and Textures, you can see my render target is right there. If I open him up, you can see I just have my, let's see, I can output this to HDR. I can make it either wrap, clamp, or mirror, and I can adjust its size, but I don't have the ability to affect what type of channel it has. And that's probably going to be more of a Daniel Wright question if that's something that is possible, but right out of the box with the system as it is now, that is not currently possible. Would this be a viable way of applying? Wait, didn't we answer this one already?
Oh, it might be a duplicate.
Okay. Well, anyway, I would not use this effect to do any type of like blood splatter or anything else that you're currently using with decals, unless decals are really falling short and they're just really not holding it up. Then possibly investigate using this. Again, this is going to be resource intensive, so whatever you decide to use this on, you need to make sure that you're taking that into consideration.
Yeah, part of me almost wants to recommend this as if you're going to build a game using this feature, you're going to want to build something around it probably.
Yeah, like and that's a great point. Like for example, maybe we make just a VR chat app, and this is part of the blackboard that we had in there that will allow both of us to paint on it.
So we can draw faces and write silly messages to each other.
And and then see, everything else in the scene is very low poly. It's
minimized.
It's very minimalistic, but all of our power is done using the billboard, right? That's we're gonna use all of our rendering time there. And that's the type of thing that you need to think about. It's not like, oh wait, let me just throw this.
Yeah, it's not like you're building like a massive RPG. Like you got Skyrim going and you're like, oh hey, I also want to be able to splash the water and it actually like splashes and all that. No, it would be like I have a game that's about I have a bucket of water and it splashes and like do something with splashing the water. So this is definitely something you kind of build around that versus something you just tack on.
All right, it looks like the last question we have is, can you use it to make in-game baked shadows with ray tracing at the start? You probably could, but the amount of work and the amount of placement, and this would just become an asset management nightmare.
Yeah.
Doing it like this, I mean, well, you could have one plane that would go underneath everything that would be parented to the object, so when you scale the object, the plane would scale with it. But anytime you had to make any type of adjustments or placement adjustments or anything like that, you'd have to go through each one and update the render target. So like, say the designer was like,
really heavy.
This game that we made that takes place at noon, we're actually changing it to 5 p.m. So the sun is going to give you these really long shadows. You'd have to go back and rebake everything and make sure that the plane is long enough to accommodate the extra long shadow that you'd want to display it on.
Oh, yeah, that's true, too.
So I would just stick to using Lightmass. Plus, Lightmass uses some ray-traced baked shadows already, I do believe.
Yeah. Yeah, I just don't think that you could just bake it out and then use it in the game like that. It'd just be too much.
I see one last question. So can you just register one impact at a time? Could you use this to say drop 2 balls into liquid and have both create waves at the same time? Yes, you could totally do that.
Totally. Yeah.
You could totally do that. You would just need to make sure that the blueprint that you make that contains the balls that you're dropping and makes a cast out to this to toggle basically to toggle the height simulation on and off when it touches it with its I think it uses your velocity. I don't remember what exactly it is. Like, I see where it is, but I don't remember what the parameter was. But you have full control over that as well. Because what I'm doing on the liquid one is you can walk over it and it will perturb the surface just a little bit. That's not too much of a stretch to add another player that would be able to do that, or to add a ball or any other type of actor that could do that.
Yeah, because it's just continuously checking for if it was like hit or not. Like, yeah, because it's just the foot that's constantly calling out to the water that it's being hit. So more feet, more hits. Yeah, it just works like that. Yeah, I think that's what we have as far as questions go today.
Yep. looks like it's it. So
Yeah.
if you guys have any questions or anything like that, please post to the forums. You can find these examples that I did in today's live stream, as well as the fluid surface actor and the 4.13 content examples. I do believe it's called Blueprint Render Targets as the name of the map. And the documentation, we have a whole new documentation section on this.
Yeah, I can find that real fast.
And I think that goes live this week.
Oh, is that not out yet?
I don't know if it's been published yet.
But you know it exists.
I know it exists because I did write it. At least I
sure.
remember myself writing it. I mean,
It was one of those weird dreams where you just totally imagined you made a whole tutorial on something. I've been there, man. Yeah.
1 second. We're going to look for you guys really quick just to see if the doc is here. Let's see, engine features, rendering and graphics. Oh, where'd I put it? That's the question.
I don't think that it's out yet.
Probably isn't.
Nope. Nope, not according to our updates. So you need to go make that go live. So that's what we have for this week, or that's what we have for today, I should say. Later on Thursday, we'll be talking more about Sequencer, and the new features came in 4.13. Still putting all that together with all the different guests we're going to have. So stay tuned for updates there. And
that's it. Thanks, guys.
Yeah.
Thanks for tuning in, everybody. We will see you next time.
Later.